Dear students, welcome to my YouTube channel. In this lesson, we will study about the Fourier series. So let's start. Fourier series. Fourier series are infinite series that represents periodic functions in terms of sine and cosine. Okay. Here, the series to be obtained will be trigonometric series, that is a series of the form a0 by 2 plus a1 cos x plus a2 cos 2x and so on plus b1 sin x plus b2 sin 2x and so on. We can write a0 by 2 plus summation from n equals to 1 to infinity an cos nx plus summation from 1 equal to infinity bn sin nx. Okay. Here you can see each term has the period of 2 pi. So if a function f of x is a periodic function of period 2 pi, then it can be represented by the sum of trigonometric series, that is the sum of cosine series and sine series. So the Fourier series are infinite series that represent a periodic function in terms of trigonometric series, that is cosine series and sine series. Here the coefficient a0, an and bn are called the Fourier coefficient. These are Fourier coefficients. These Fourier coefficients are determined by the formula called the Euler formulas. That is a0 equals to 1 by pi minus pi to pi f of x dx, an equals to 1 by pi minus pi to pi f of x cos nx dx, and bn equals to 1 by pi minus pi to pi f of x sin nx dx. These are Euler's formula for your coefficients. So now let's evaluate this Euler's formula. Okay. To evaluate a0, an and bn, we need to use the orthogonal properties of sine and cosine function, that is integration from minus pi to pi sin mx cos nx dx equals to 0 for both the condition m not equal to n and m equal to n, and minus pi to pi sin mx cos nx sin mx sin nx dx equals to minus pi to pi cos mx cos nx dx equals to pi into Kronecker delta mn. We know the properties of Kronecker delta, that is Kronecker delta mn becomes 1 when m equals to n and 0 when m not equal to n. So this integration gives two values, that is pi when m equals to n and 0 when m not equal to n. Okay. To evaluate a0, integrate the equation 1 both sides term by term from minus pi to pi. So equation 1 becomes minus pi to pi f of x dx equals to a0 by 2 minus pi to pi dx plus first term will give x from minus pi to pi, and we know the integration of cos theta is sin theta, so second term gives sin nx by n from minus pi to pi, and the third term becomes integration of sin theta is minus cos theta, so minus of cos nx by n minus pi to pi. Okay, so now let's put the upper limit and lower limit. We get pi minus of minus pi, and in the second term we get and third term becomes, take minus 1 common, minus cos of minus n pi by n, a0 by 2. First term will give 2 pi plus n equals to 1 to infinity a n sin n pi by n minus sin of minus theta is minus sin theta, so minus minus it becomes plus, so the second term becomes sin n pi by n, and the third term becomes minus 1 cos n pi by n minus, we know cos of minus theta is cos theta, so it becomes cos n pi by n. Okay, 2 get cancelled, so it becomes a0 pi plus, here sin n pi is 0, sin n pi is 0, third term also becomes 0. Okay, that implies f of x dx equals to a0 pi, that is a0 equals to 1 by pi integration from minus pi to pi f of x dx. This is the Euler formula for a0. Okay, next is an. In order to evaluate an, multiply the equation 1 by cos mx and integrate the both sides term by term from minus pi to pi. So equation 1 becomes of x cos mx dx equals to a0 by 2 minus pi to pi cos mx dx cos summation n equals to 1 to infinity an integration from minus pi to pi cos nx cos mx dx plus bn minus pi to pi sin nx cos mx dx. Okay, equals to a0 by 2 integration of cos mx is sin mx by m minus pi to pi, and the second term becomes n equals to 1 to infinity an. Here use the orthogonal property of cosine function. Okay, so second term gives pi into Kronecker delta nm. Okay, in the third term use the orthogonal property, so it becomes 0. Okay, so equals to a0 by 2, put the limit sin m pi by m minus sine of minus m pi is nothing but minus sin m pi, so minus minus becomes plus sine of m pi by m plus n equals to 1 to infinity an pi into Kronecker delta nm. Sin m pi is 0, so first term becomes 0, and the result becomes summation from n equals to 1 to infinity an pi into Kronecker delta nm. According to the properties of Kronecker delta, we can write an, because one of the properties of Kronecker delta is summation aj Kronecker delta jk becomes ak. Here the summation index j is contracted. Here also summation index n is contracted, so it becomes m am. Okay, and pi is there, am pi. F of x cos mx dx equals to am pi. That implies am becomes 1 by pi minus pi to pi f of x cos mx dx. Okay, hm is a dummy indices, so we can write n in place of m. So an equals to 1 by pi minus pi to pi f of x cos nx dx. This is the Euler formula for an. Okay, next is bn. In order to evaluate bn, multiply the equation 1 by sin mx and integrate both sides term by term from minus pi to pi. So equation 1 becomes minus pi to pi f of x sin mx dx equals to a0 by 2 minus pi to pi sin mx dx plus summation an minus pi to pi cos nx sin mx dx, and the third term becomes bn minus pi to pi sin nx sin mx dx equals to a0 by 2 integration of sin mx is minus cos mx by m, limit is minus pi to pi, plus in the second term according to the orthogonal properties it becomes 0, so second term is 0. Okay, and the third term according to the orthogonal properties it becomes pi into Kronecker delta nm. So the third term becomes pi into Kronecker delta nm. A0 by 2, take minus common and put the upper limit and lower limit. We know cos of minus m pi is nothing but cos m pi, so cos m pi by m plus n equals to 1 to infinity bn pi into chronic or delta nn. First one becomes 0, so the result becomes n equals to 1 to infinity bn pi into chronic or delta nn. So here we can also write according to the properties of chronic or delta, we can write bm bm pi, because one of the properties of chronic or delta is aj chronic or delta jk, it becomes ak. Here the summation index j is contracted. Okay, so equation becomes minus pi to pi f of x sin mx dx equals to bm pi. So bm becomes 1 by pi minus pi to pi of x sin mx dx. H m is a domain indices, we can write n in place of m. So bn equals to 1 by pi minus pi to pi f of x sin nx dx. This is Euler formula for bn. Okay, so now let's prove the orthogonal properties of sine and cosine function. To prove this integration, we use the trigonometric formula sine a sine b equals to half of sine a plus b plus half of sine a minus b. So this integration becomes minus pi to pi half of sine m plus n x dx plus half of integration minus pi to pi sine m minus n x dx. Okay, the first term becomes minus of cos m plus n x by m plus n minus pi to pi plus, and the second term becomes half of minus of cos m minus n x by m minus n minus pi to pi. Okay, here the both the term first term and second term becomes 0 after putting the upper limit and lower limit, so the result becomes 0. This is for both the condition m not equal to n and m equals to n. Okay, to prove this integration, we use the trigonometric formula cos a cos b equals to half of cos a plus b plus half of cos a minus b. Okay, so integration becomes minus pi to pi half of cos m plus n x dx plus half of cos m minus n x dx. Okay, and the first term becomes sine of m plus n x by m plus n minus pi to pi, and the second term becomes half sine of m minus n x by m minus n minus pi to pi. Here you can see both the term first term and second term becomes 0 after putting the upper limit and lower limit, so the result becomes 0. This is for the condition m not equal to n. Okay, for the condition m equals to n, the integration becomes minus pi to pi cos square nx dx. We can write minus pi to pi. We can write cos square nx equals to 1 plus cos of 2 nx by 2 dx. Take 1 by 2 common. minus pi to pi dx plus minus pi to pi cos 2nx dx. Integration of first term is x minus pi to pi, and the integration of second term is sine 2nx by 2n from minus pi to pi. Okay, the first term gives 1 by 2 pi minus of minus pi, and the second term becomes 0 after putting the upper limit and lower limit. Okay, you can check it by yourself. So the result becomes 1 by 2 into 2 pi equals to pi. Okay, so for m equal to n, integration is pi, and for m not equal to n, integration is 0. Okay.